All right. We'll go ahead and get started. Thank you, everybody, for coming out tonight. Appreciate it. So the topic that we're going to be talking about today is machine learning for high schoolers, right? We're going to talk a little bit about what machine learning is, the challenges to learning machine learning as a younger student, so students in middle and high school, and then give a little bit of an idea of some projects that are within reach for these early learners, these young learners. So yeah, let's get started. All right, so to start a little bit about me, my name is Kai. I am the director of machine learning at Breakout Mentors and a data engineer, data scientist at a real estate technology company called Referral Exchange. I'm the founder of a company called Music AI, which uses artificial intelligence to help discover emerging artists and music talent. And I am also the co-creator of Heart Bio Portal. So a little bit about me. Let's get into the good stuff. So machine learning, it's everywhere. It's a hot subject area, kind of like, the metaverse or crypto and things like that. But yeah, machine learning really over the last decade has infiltrated pretty much everything and elevated a lot of the technology we use every day. So everything from spam detection in our email to autonomous driving, self-driving or driving assistance, and your recommendations on Spotify or Netflix, all that kind of good stuff. A lot of the power is driven through machine learning algorithms and developments in that area. But it's ubiquitous, it's everywhere, machine learning's everywhere, but really what is it, right? That's one of the questions we're going to answer today. So a prominent AI pioneer, Arthur L. Samuel, back in 1959, he was quoted as saying, "Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed." But to really kind of understand what this phrasing means, it's helpful to frame it first from a traditional programming perspective and then move over to the machine learning perspective. So what is traditional programming, right? What's the traditional programming paradigm? It looks something like this. A programmer is given some data and a task, and then their goal is to write a program to achieve the desired result. And basically the workflow looks similar to something like this, right? That we see here. The program that they write is going to define the relationship between the inputs, our X values, and the outputs, our Y values. So they're going to take a look at the data and by hand uncover what the relationship is between the inputs and the outputs. And then in their program, they're going to write a code that defines this relationship. And they're going to do all that by hand, right? So in the machine learning approach, the machine learning paradigm, what's going on is, a data scientist is given some data and a task, just like in the traditional programming paradigm. But the difference here is the data scientist is going to define a model and use that model to learn a program that achieves the desired result. So the key thing to keep in mind here is in the machine learning paradigm, what they're doing is instead of defining the relationship between the inputs and the outputs by hand, they're going to define a model that is able to learn the optimal relationships between the input and output using data, which we'll go into more detail in a second. But this is, kind of the structure of what that looks like. So I think this is best understood when we go through an example application. So let's say that we have been approached by a big time movie studio and they want to have a better idea of how much revenue they can expect from a movie project they invest in. So basically, we're given the task of writing a program that can tell them around how much revenue they can expect based on the budget that they put into a movie. So using the traditional programming paradigm approach first, what we'll do is we're gonna take a look at our data, right? And we're gonna visualize it. So we visualize it here, and we can see this data looks somewhat, linear. It looks like I could probably draw a line through it. And if we remember from, our high school freshman math class, we remember that in order to define a line, we use y equals mx plus b, right? So as a programmer, we're going to try to find this relationship in between our inputs, our budget, and our outputs, our revenue. And we're going to do that by hand. So what we need to figure out is what is the slope, our m, and what is the y-intercept, our b, right? So we take a look at our data, we're diligent, and we start to realize a pattern. We recognize a pattern, and we see that if we multiply the input x, our budget, by 2, and then add 1.5 to it, we're going to get the desired revenue. So what we're going to do now in our program is we're going to write the code. So we're going to define that relationship in our code, in our program f of x. So this is what that looks like. And then, a practical application of it is the big time movie studio wants to know how much money they might make from a movie that they invest $15 million in. And now our program can tell us that we can expect about $31.5 million back in revenue. So pretty good, right? But what's the catch? So what if we couldn't have found the relationship by hand in that data? I know, in that example, the data was fairly simple. We only had 4 data points. It was linear. We could fit a line directly through each of the data points. But in real life situations, unfortunately, it's rarely ever that simple. Data often looks more like this. So we'll see if we take a look at this data set of movie budget and revenues, we can see that there's more scatter, right? There's more spread between the points. There's more data points, and it's messier. There's more what we call noise. So how would we go about finding that relationship between the inputs and outputs? Well, this is where traditional programming falls short and where machine learning really excels. So in a world that is really, we're creating so much data, machine learning is the optimal solution for a lot of things. And what does this kind of look like? So solving this same problem from the machine learning paradigm approach, what we're going to do is define a model. So we're data scientists, we take a look at our data, and now our goal is to define a model, and then we're going to learn the optimal relationship between our inputs and outputs. So what does that look like? We take a look at our data and we see, we still think a line is fairly representative of our data points, right? So we're still going to use that same y equals mx plus b. But now what we're going to do is, instead of by hand figuring out what m and b are, we're going to just define which parameters we want to learn. Okay, so our model is going to take in our inputs and then these parameters, which we defined as m and b, and then it's going to learn the optimal values for those m and b's, the m and b values. And this, this is kind of at a high level, visually, this is what that process looks like. It's iterating over and over again. And in code, this is what that machine learning process looks like. So similar to when we hard coded, right? So in hard coding, we had our program f of x. Now, when we're using the machine learning paradigm, we have our model f of x, and now we notice these two additional inputs, this m and b. So what's going to happen is we define our model, and then we prepare our data, our inputs and our outputs. And then what we're going to do is we're going to train it. So that training process, this learning process, is going to take in our data points, our x and y's, and then our model, which we defined up here. And then it's going to perform this process over and over again until it reaches the optimal values for for m and b. And then practically, why is this useful? Well, solving that same issue, the movie studio says we're going to invest $15 million in this new movie we're making. How much can we expect to make in revenue? And using our trained model, which will produce the desired result of 31.5. So it's very similar to the traditional programming paradigm, except now we are able to learn the relationship automatically between the inputs and outputs instead of having to figure that out by hand on our own. And you can easily imagine how in nowadays with data so ubiquitous and so much of it, how machine learning is really the only practical option for a lot of problems where we have a ton of data. So a quick summary of what machine learning is, right? Machine learning, you shouldn't be intimidated by it. It's like regular programming. It's a way to get computers to complete a specific task. The key difference here is that instead of defining the relationship between the inputs and outputs by hand, we're going to define a model that learns that relationship from the data for us. So the main idea is, when we can't define that relationship between our inputs and outputs easily, we're going to use machine learning to figure out that optimal relationship for us. So, we just went over kind of what machine learning is, but you might be wondering, can it be a little bit more complex than what we just saw in that little example, right? So can machine learning handle complex data? Absolutely. Can it learn nonlinear relationships in data? Yes, that's one of the most powerful things about machine learning, and especially deep learning, which is a subfield of machine learning. Can machine learning models have more than 2 parameters? Yes, in fact, some of the more recent machine learning models have billions. I think actually the biggest model today has over 1 trillion parameters, believe it or not. And then, what type of data can the machine learning model learn from and ingest? So what can our inputs be? Pretty much anything, which is really, really cool and exciting. So complex data like images, videos, text, sound, so like audio, all of those things are valid inputs to machine learning models, and the models are able to learn ideal relationships between the inputs and outputs depending on what the end goal is. So now that we kind of have an idea, of what machine learning is, right? Now what we might be thinking is, what makes it difficult to learn? Because learning machine learning is actually, it's quite hard. And this is especially true for young learners, middle school and high school students. But why is that? Why is it very challenging for the younger students? So I think this boils down to three issues with traditional machine learning curriculum that you see available either online or on college campuses. the three things. So if we see here, we see, you know, this is an image of an example of what you might see inside of a machine learning textbook, or when you're at a machine learning class, either online or on campus. Obviously, you know, this can be very intimidating, where it's very math heavy, lots of math equations, and very theory based. So that's especially for younger learners growing up in a digital age. You know, patience is a hard to find commodity nowadays, it seems like, right? And so keeping things interesting and interactive is really important. And traditional machine learning curriculums really aren't structured that way. They're very, again, theory intensive, math intensive, and this leads to students being quickly bored, intimidated, and confused, which is the opposite of how we want them to feel when they're learning anything, but especially a very applied topic like machine learning. Another problem that is challenging with traditional curriculum is there's just so much to learn. So a lot of curriculum try to teach a huge amount of breadth really early on before the students start to dive into any projects. And that can be, you know, that can cause low retention for students. So they're not remembering everything they're learning. They're feeling overwhelmed. And it's easy to get discouraged because, you know, you see that, wow, there's so much I don't know, that it can make you, you know, feel bad and lose interest. And then the third thing, and I think this is a really big key thing that is not often talked about, is compute and data, so resources. So machine learning requires a lot of computing power, and it requires generally a lot of data, right? And traditional machine learning curriculum doesn't really focus on enabling students to access the resources they need to be able to apply machine learning skills. Again, it's very theory heavy, math intensive, and less on putting it into practice and getting to play around with it and building up an understanding through that type of approach. And that's a really hard barrier to overcome, especially if you're newer to either programming or machine learning in general. It can be very intimidating. I know when I was first learning, really there was only two options. You either worked at a big tech company that had, you know, data centers that you could borrow some compute power from, or you built your own computer, supercomputer at home. And I opted for building my own computer. Definitely, nowadays I wouldn't recommend that, but it was the best option available at the time. So, you know, what are some ways that some tips and tricks that we've developed to help overcome these issues for young learners and make learning machine learning easier and more enjoyable for them? So our goal with the students we work with in machine learning is really a project-based experiential learning environment. So we really focus on, instead of diving excessively into complex theory and overwhelming them with math, we really try to focus on developing a really strong intuitive understanding of the fundamental concepts of machine learning through interactive learning environments tailored specifically to the students' interests, and working on real world data sets and building machine learning apps right away. So like in our curriculum, actually, like from the very first day that the student starts with us, they are building out projects right away and getting to work with code and develop things and build machine learning models from day one. And one of the things that I kind of like to call our curriculum is we focus on teaching the whole game. So what do I mean by that is, if you were to try to teach a student how to play basketball, um, it would feel wrong, at least in my opinion, to sit the student down and explain to them the physics of how a ball bounces and the physics of shooting a ball and the arc that it has to make and things like that. Instead, a much more natural way of getting the student interested and motivated and learning is to either take them to a basketball game or to play basketball with them right away. So we adopt that same type of philosophy when we teach machine learning, and we find that students learn more effectively and stay motivated and learn more with that approach, as opposed to front loading a lot of the theory and the math. And then again, we really focus on that learn by doing. So project-based learning is really the best way to learn machine learning. It's very applied, and you dive deeper into the theory and the complexities in the math as you try to solve more challenging problems. So it's a natural way to kind of go about the learning journey. And traditional machine learning curriculum were structured for an age before the internet was super easy to access and everybody had a laptop. But nowadays, everybody has a laptop, data is accessible, and why not? You should be doing projects as much as you can. It's more fun to learn. So we really focus on doing that with our students. And then again, the last thing, addressing that last problem, which is access to resources, compute, things like that. We focus on enabling students to access free, powerful compute and teaching them how to use state-of-the-art tools, all for free, to build machine learning apps and train machine learning models and access data, all for free. So again, just summarizing, we address the problem of being overwhelmed by math and theory by teaching the whole game, developing a high-level understanding, learning by doing, and removing any of the barriers that prevent learning and working in an interactive learning environment. So what does the learning journey look like for a student that goes through our summer machine learning program? Each student is paired with an expert machine learning mentor who's from a top school in machine learning, and then they go into our deep dive. So what the deep dive is they're working with their mentor. They're meeting them 2 to 5 times a week for an hour and a half, typically each session. And they're going through our semi-structured curriculum. So the semi-structured curriculum, which we call our deep dive, develops the students' intuitive understanding of all the foundational concepts and tools that they need to be able to build their own machine learning apps completely from scratch. And it really gives them a good launch point to get into machine learning, get motivated, and figure out kind of what their interests are, and also how to think like a machine learning scientist. And then once they've completed the deep dive, they move on to the capstone project. So that's a really exciting time, and it's broken down into 2 phases. So first is the planning phase, and then the execution phase. So in the planning phase, the student, the mentor, and myself get together and we look at, what's the student's interest, what's the student excelling at, what do they want to work on, what do they want to get better at, and then we together come up with a project that they can reach within a reasonable amount of time over the summer. And then this application, the goal is so that they can share this application with the world, their friends, their family, on college applications, things like that. So in the past, students have done things like, we've had students really interested in the environment. We've had a student who built a machine learning app that could take the sounds of the rainforest and then detect which species were present in the rainforest just using sounds. We've had other students interested in, like medicine and things like that. So a student built an app that could predict the risk of a heart attack occurring in a patient based on, health metrics and things like that. Lots of exciting projects for students to do. And then after they finish working on their capstone, where they're working, again, similar to the deep dive, they're meeting 2 to 5 times a week with their mentor. After that, they move on to what we call the long-term learning phase. So this is the point of this is to encourage sustainable long-term learning and development in their machine learning skills. And they transition from meeting with their mentor 2 to 5 times a week to once a week, typically, occasionally 2 times a week if they really want to, throughout either the remainder of the summer or throughout the school year, depending on when they get started. And they continue to work on more and more complex projects and dive into more and more complex components of machine learning. And again, the goal here is to build out more projects for the student, with the student, and also to help them further their understanding and dive into different areas that they're interested in. So what does kind of, student success look like for students that have gone through our summer machine learning program in the past? We've had students compete and earn awards in state and international data science competitions and science fairs. Several students, we've had many students build out, machine learning applications that help them stand out, and they showcase on their college apps. And this has helped them gain acceptances into top, schools like Ivy Leagues and top schools on the West Coast. And then we've also had a handful of students who have actually been able to use their machine learning projects, the capstone projects they've developed, to land internships where they get to apply their data science and machine learning skills. So that's really exciting for them. Now, I see in the chat. So, and I'll answer questions at the end. So feel free to, type in any questions in the chat, and I'll do my best to answer them. So, now that we have an idea of what machine learning is and how we've developed curriculum so that it's more approachable and fun for young learners, what are some machine learning projects for middle school and high schoolers that are within reach and make sense, right? So some of these are examples of projects that our previous students have worked on, and some are just examples of project ideas that could be done within a summer with us. So we'll start. I'll just talk about one of the bullets on each section, but here we're looking at the subdomains of biology, medicine, and mental health, all popular areas for a lot of our students. I'll speak to the Twitter user sentiment detection. So we've had students who have built out applications like a machine learning powered application that could detect the sentiment of their friends, their friends' tweets. And you could see an application here for if your friends' tweets are sadder than they normally are, if the emotion detected in it seems a little bit more gloomy, maybe you reach out to them and check in on them, see if they're doing all right. So that's an example there with practical applications. Then we have finance and business. So lots of exciting areas there for students interested. Things like predicting stock value, customer churn and retention, abnormal product sales, lots of different exciting application areas within reach there. Another really big one, exciting one, is climate, sustainability, and environment. So I'll talk about two of the projects students have worked on in the past. One student built a machine learning application that took in satellite images of forests, and then based on those satellite images could predict where a likely fire was to outbreak in those forests. And obviously, that has practical applications, lots of safety things that and can save a lot of people and be very useful. And then another one is using images from crops of crops and detecting whether crops are developing, like if a disease is appearing on any of the crops, so that you can quickly address the issue and prevent the entire crop from being spoiled. So those are two cool applications that students have built in the past. And then the last one I'll talk a little bit about, and this is one that's really exciting and a lot of fun for a lot of our students, is building ML powered applications that are for creativity. So, like art, music, and poetry generation. We've had students interested in music who develop machine learning apps that can generate unique music in the style of different musical composers and artists, generating lyrics, things like algorithms, machine learning apps that can generate specific, they take in an image and then a style or an art piece and then merge them together, as we see here, right? So we have a picture of Stanford's campus, and then the Van Gogh's Starry Night, and then these two are merged together to create this image. So that's using an AI powered application that generates that. And then another really exciting area, which I'll go into really quickly, is and this is really kind of taken off over the last 2 years, is transforming text descriptions into realistic photos or art. So I'll talk a little bit, I'll showcase kind of what this looks like. So this isn't specifically a student's project, but this demonstrates what I mean by inputting a text description and an AI outputting a realistic image from it. So here the text description is an astronaut playing basketball with cats in space as a child's book illustration. Let's try another one. So here we're gonna use teddy bear, and let's say working on new AI research on the moon in the 1980s. So this is an image completely generated by AI based on this this text description input, which is really incredible. And these projects are within reach for students. They may not be making an image that's this amazing in quality, but they can make things that are quite impressive, like these two examples here. So yeah, that's kind of a quick rundown of projects that are within reach. And then to kind of summarize before I open it up to QA is, we talked a little bit about what machine learning is, and then why traditional machine learning curriculum is difficult for young learners to jump into and learn machine learning, and then our approach to how we help those students get into machine learning and learn from it and stay motivated and overcome those roadblocks. And then we also talked a little bit about and showcase some machine learning projects that are within reach for young students. So yeah, again, thank you so much for joining. If you guys have any questions, I will answer them right now. So let's see, we have a couple questions here. So one question is, are the free data centers where students can borrow compute power on a regular basis still available after the course, or is that only available during the course? to answer that question, yes, the data centers are available after the course. And our goal is, the goal is not to create a dependence, but to create independence. So we want to empower the students to eventually become their own, comfortable enough to work on their own and build their own applications without the help of a mentor and things like that. So they are able to access those after the course as well. And then in terms of what, another question is, what level of math is necessary for students to begin working in our program? We think as long as what we've are in our experience, what the only thing that is needed in terms of a math background is you're able to understand the equation for a line. So y equals mx plus b, what I showed earlier. So, you know, for most students, that's either in 8th grade or around there, or their freshman high school math class when they get that. So we've had students come in who have a basic, you know, 8th grade or 9th grade level math experience, to students who come in and they've already taken some upper division college, you know, like linear algebra classes. All our curriculum works with both of those students, and they are able to succeed and achieve amazing things from both starting points. So it's exciting that way. This is an interesting topic. So has machine learning been used to create podcasts on keyword topics? It's an active area of research that is currently being explored. Machine learning is used to understand what's being talked about in podcasts right now. So, you know, Spotify is an example. They're pouring a lot of money into getting a better understanding of the type of content that each podcast has, so that they can offer better recommendations. There is also podcasts, experiments, research going on about generating full-length podcasts from you know, keywords and interest areas. And that's similar to things that are going on with the text generation too, where you know, you prompt the machine learning algorithm with a subject and you ask it to write an essay for you on that subject. And some of the results are quite amazing. Let's see. Another question again about the data centers. So same question as before. Yes, the data centers are available to the students after they take our course for free, as long as you know, as long as they want to keep learning machine learning, they're available. So, and then another question: what programming languages do we use? So, students, we teach machine learning in Python, so an object-oriented programming language. In terms of coding experience that we expect as kind of, you know, a prerequisite, we ask that students come in with at least 6 months of experience coding in any language. So it doesn't have to be Python specifically. And you know, if you're questionable on that, just you know, follow up and schedule a call with me, and I'm happy to discuss potential options and fit for that student, and whether machine learning would be a good first step for them or not. Where do the kids get the data sets? Another good question. So there's too many resources to outline on this podcast, but on this webinar, excuse me. But we show them various different ways to get access to the data sets that they need, whether it's through, you know, web scraping or different resources that provide data and things like that. But yeah, we show them how to access all the data that they need. What's the estimated cost for this program? So you can go to our website to see costs for monthly packages and things like that. But people that do the summer deep dive, the cost is $1,800 for the deep dive sessions and capstone period. And then if they need additional lessons after that, there's each session after is I think $100. So yeah, so that's around. Generally, it takes students are able to produce a solid project within the time of their deep dive program. So the 1,800 gets them to where they understand all the foundations of machine learning, and they produce a project that they can show off and are proud of by the end of the summer. Does another good question, does the mentor help the student figure out a project if they have no idea what they want to do? Yes, so great question. I mentioned this a little bit earlier, but the capstone project phase is separated into two components. So there's the planning phase and the execution phase. In the planning phase, I'm involved, the mentor is involved, and the student is involved. And we get together and discuss, where the student is at in their experience level, and what they're comfortable with, and then also what they're interested in. And we work together to craft a project or pitch projects to them that might be interesting and that they're excited about. And then, they'll pick a project and go for it. So, and then we help them along the way. Do students learn? Okay, so can we see the actual projects of past students? Yeah, so on our website, you can go visit. We have an example of a student who we interview as well, and they talk a little bit about their project and things like that, and showcase what their project in action. So yeah, so if you go to our website, breakoutmentors.com/machine learning, or just go to breakoutmentors.com and then go to the articles section, you'll be able to see the article on that student's previous project. Do students learn to analyze biases in their data and models? So I'll answer a couple more questions. Do students learn to analyze biases in their data and models? Yes, yeah. So that's a really important topic area in machine learning that is often lacking in traditional machine learning curriculum. And it's something that we stress a lot, both with the mentors and the students. So, we are all about being inclusive and, ethics minded. We want to do the right thing. So yeah, so students will learn about biases in their data, and we talk about early on, that your algorithm will only learn what's in the data. So, if your data is biased and not representative, then your model is going to do the same thing. So, the phrase is garbage in, garbage out kind of thing. So yeah, we do stress bias and in stress ethics in developing machine learning algorithms. How many hours is the program typically? This will be the last question I answer. Yeah, so the program typically, like I said, if we go back to this, depending on the student, how much they want to work on projects on their own in their own time versus how much they want to work on projects only with their mentor, can take anywhere from, I would say, 25 hours to 45 hours of work over the summer. So yeah, that's one of the reasons why the summer is a really good time for these students, because they can crash course into machine learning and spend some time focusing on it, and then really working on a capstone project that they're proud of, and spending 10 to 25 hours on that. So yeah, awesome. Well, again, I just want to thank everybody for coming out and joining me and hanging out today. I hope you found this insightful and helpful. And, I really appreciate everybody's questions. They were great. If you want to get in contact with me, please feel free to schedule a time to talk with me over the phone by visiting this link. If you want to sign up, if you're already sold and you want to sign up for our machine learning summer deep dive program, we just opened up signups, and spots are limited. So go ahead and visit this link here. If you want to learn more about what our philosophy to teaching machine learning and our approach to it, please visit breakoutmentors.com/machine learning. And as always, you're welcome to shoot me an email if you have any other questions or follow-up that you want to ask me. But yeah, again, thank you guys so much for coming out. I really appreciate it, and hope everybody has a great rest of their night. Thank you.